In this video, I'll be showing you how to create random numbers in Java. First, I'll be using the Math.random method. I'll also be showing you how to create objects of the random class. I'm going to be using this formula in a bit, but I'm going to go through and explain exactly what the parts are doing. Math.random. This is calling a static method random on the math class. This is a capital M. And if I go and print it out in a for loop of 10, see, it gives me a bunch of numbers. This is in fact giving you a double between 0 and 1. Technically 0.0 is a possibility, but that upper boundary 1 is always excluded. Now Math.random on its own is kind of pointless. Who wants numbers between 0 and 1? Until you realize, hey, I can multiply this by some range, 10. Now this gives me numbers between 0 and 1 multiplied by 10, essentially giving me a bunch of doubles from 0 to 9. But say you want to do integers, you can cast them to an int. Why did that not work? Well, it did the casting on this part first. You need parentheses around your multiplication. Now it gives you numbers between 0 and 9. It's hard to prove this just by running 10, but you do hundreds of tests, you find this is a uniform distribution. Now most humans like to count starting at 1 instead of 0 like computers do, so you can just add a plus 1. This is your starting boundary. And see, if I run this a few more times, you'll see I never get 0. And 10 is a possibility. There we are, 10. This is giving me numbers between 1 and 10. Of course, you could change the boundary and say, hey, I want to start at 10. And of course, if you wanted doubles, you just get rid of this int part. You can replace the int casting to Math.round, which is another handy method, and it gives you the same kind of thing. You can also use the ceiling and floor functions. I just prefer int because it's shorter. Now I'm going to introduce a few variables. Min and max are self-explanatory, and then range is calculated by max minus min, so 15 minus 5, that's 10. But then, since Java always excludes that upper boundary, we have to add 1, making the range 11. Now we can evolve this formula, replace the print. This is saying, get me a random number, multiply it by the range, and then add that minimum starting value. Say I want to start at 5. This gives me random numbers from 5 to 15 inclusive. It also works for negative starting values because range is 15 minus a negative 5, which is 20. And then we add 1 to include that upper boundary. And you see, if I run this a few times, I get a few negative numbers, and it gives me some positive numbers. But the positive numbers, see 11, is bigger, and it never goes beyond negative 5. This formula works. You could eliminate these variables, of course, but it might be helpful to understand what's going on in the first place. This adding a min is really helpful, because most of the time we want to generate numbers starting bigger than 0. Another approach is to create a random object. I'm going to call it generator equals new random. Now this is going to give me an error until I import the random class from Java U2. Of course, you could just type the statement. We're going to replace the print. Gen dot nextDouble. This gives you almost identical behavior to Math.random. It gives you a double between 0 and 1. Again, not extremely helpful, but you can multiply this by 10 or 20. For doubles, of course, you could round them down if you didn't want all these decimals of precision. And you can add a starting index. You say, I want a range of 20 numbers, starting at 10. But random also has this method called nextInt, which when you run it, may seem strange at first, because these are huge numbers and they're all over the place. Well, Java's numbers are 2 to the 32, which approximately gives you about 2 billion negative numbers and 2 billion positive numbers. Most of the time you don't need that giant of a range, so you can also pass in a parameter, say 5. I want numbers in the range 0 to 5. This is like the range we calculated up here. This is starting at 0, so you can add 1 to start counting at 1, and you see it's going from 0 to 5, then 5 is not included, but then it's adding 1. So essentially, 5 is included here. Lowest is 1, highest is 5. This is the min part, and you can also start at like negative 20. It gives you negative values in a range of 5. So starting at negative 20, going all the way up towards 0. Unfortunately, nextDouble does not work when you pass it an argument. See, if I run this, I get a compile error. That's because this is undefined. You can only do numbers between 0 and 1. And then you'd have to use our earlier multiplication and adding a starting index tricks before. But it's not that complicated, and if you want to, you can always use these numbers to help you out. Just with a random object, you have a few more options because you can say, I want to get an integer, instead of casting it after you've found that value. And it might eliminate the need for the variables if you don't need them.